Over the last 2 years, I've built over 24 headless guitars using all kinds of different hardware from various brands. Now, with the bridge themselves, I'm usually quite happy, and I've found various ones that I like a lot. However, for some reason, the much more simple headpiece, which is where you lock the strings at what usually would be the headstock, those I somehow never found one that I really liked. On some of them I like the design and the way that I can place them, however they have very small screws that strip easily and don't hold the string quite as secure. Others have larger screws that I prefer, but they're a bit too big, so I have to space them out, which causes the strings to fan out. Of course, there's also block headpieces which have sturdy screws and can have them close enough together. However, they tend to look very bulky and don't kind of fit my slightly angled and flowy headstock design. So I've known for a long time that the only way out was to build my own. And it's actually a fairly simple part that I can easily make myself on the CNC. However, I've always had bigger fish to fry, so it took me quite a while to actually get around to it. After I built my new CNC about a year ago, I had zero excuses left because now I have an automatic tool changer which makes manufacturing these a lot more simple, as it does require quite a few different tools that only are active for a couple of seconds. So having to change them manually would cause this to take 10 times as long. But before we get into machining these headpieces and finishing them, let's have a look at the design. Here you can see the 3D model for the 6-string version of it. And as you can see, it has kind of this swooped design. And this is so that it can fit my headstock design that I like to do on my guitars. Now, the 6-string model usually has a straight nut and then slightly fans on the lower frets. However, to kind of complement the body contours, I still kind of angle up the base side of the headstock a little bit to this shape. So I just kind of took in the sides a bit and made it fit. Now, what is actually locking down the screws are these grub screws here, and they are quite beefy. They are M5 grub screws, which is basically the largest that you can use here. And this means that it is very hard to actually strip this hex. Now, some headpiece designs, like for example the ones from Technology for Musicians, which I actually really like, however, they use M3 grub screws here, which are still plenty strong enough to hold a string. But it is quite easy to strip out either the hex of the grub screw itself or the kind of tool that you're using. So I definitely wanted to have the largest possible ones, so I'm going with M5 here. Then to actually attach this headpiece to the guitar, the easiest way is to just have a little extra material here. I have some screws going in and attaching it to the headstock. That's how the block headpiece, for example, from Nova Guitar Parts works, but this tends to make it look quite bulky. Another alternative would be to actually use these holes here, and in the bottom here have a hole going through to the headstock and putting a screw in here, and then you can add a little plate that covers it so the string sets on. That's what a lot of single headpieces, like the Nova single headpieces, are using, and this works. It hides this screw. However, it means that you have to use quite a small screw in here, which is somewhat annoying to install and also not quite as strong as it could be. So if I don't want to add an extra tab and I don't want to use these holes, well, the only other alternative is to attach it from the bottom. So that's what I'm doing here. I'm screwing through the headstock and have two M4 threads down here at the bottom, which allows me to use heavy-duty M4 bolts to attach it. This is much stronger than using small, like 2 or 3 millimeter wood screws, and also is much simpler to install, as I simply have to screw in these two easily accessible bolts. Now, with the design all covered, let's see how I'm actually building these. Now, to manufacture them, I need to access features from 3 different sides, so I naturally need 3 different operations. Here you can see the setup for the first operation. I'm using my Saunders Machine Work mod vices here. They're just ideal for this kind of work. For the first operation, I'm just using my rough aluminum or brass stock in here and clamping it with the serrated jaws. This clamps it very firmly in place, and I can machine the top here, then go around the contour and finish up the contour. To prepare the holes for threading, I'm boring them out with a single flute end mill, This works a lot better than drilling, and it also leaves a flat bottom. Then I go around chamfering everything, and finally I'm using an M5 single point thread mill, and I'm thread milling these threads here. I'm cutting them in 2 passes, which works quite well. I did a couple of test pieces to make sure that the grub screws fit in nicely. The threads are tight enough, but still don't like bind up or anything. And we'll be anodizing the aluminum parts as well afterwards, so the material will grow ever so slightly, so I need to make sure that it's not too tight in the raw aluminum, otherwise it's going to bind up later. With all the features on the top completed, we're moving on to op 2. For op 2 I made some soft jaws, which are just these little aluminum blocks that I can screw onto the modwise bases. And I machined in kind of the negative shape of this very curved feature that would be basically impossible to hold in a vise regularly. Then with this feature in here, I can simply slot it in here, and since I machined this feature on the machine, I can use just like the corner of this aluminum block as my reference point, and I don't have to probe any complicated surfaces on the part, but can probe a known surface already. This makes it very repeatable and ensures that everything lines up nicely. Here I just face off the rest of the material that is left over, bore out these holes, go around with a bit of chamfering, and then do the thread milling of the M4 threads here. Doing the chamfer of the contour that I was machining on the first side is also a really great test to see how well the XY alignment corresponded when flipping it over. If the chamfer is nice and even all around, then I know that I flipped it around perfectly. And I had 0 issues with this in this case, thanks to using these soft jaws. In the third operation, what is left is drilling the holes for the strings, and this is quite a difficult operation because the part needs to be held at a perfect angle, and the alignment also needs to be quite close so that they intersect nicely in the middle with the already machined holes. Now, in order to hold this at the correct angle, I 3D printed this kind of little fixture. Just used my resin 3D printer to print this out. I could have also done it on the FDM printer, but doing it on the resin just kind of left me with a smoother surface. I also designed it in a way where I can use part of this fixture here that is holding the part as kind of my reference for my datum. For the y-axis reference, I'm using the jaw itself, and then for z and x-axis I am using part of the fixture. This allows me then to come in with a small end mill and start drilling these holes. Of course, this small 2mm end mill cannot reach all the way through. It is quite a difficult hole to make actually, because it starts on a slanted surface, and then it is a 2.5mm hole that goes maybe 8mm deep. So it's quite a deep hole to drill, and there is a cross hole in the middle. So the top half of the hole I am interpolating with a 2mm end mill, and then I'm switching over to a 2.5mm drill bit, which then is guided by the top half of the hole, so it doesn't have to start on an uneven surface, but it's guided through and already held nicely in place, and can easily drill the second half of the hole. Doing this kind of combination approach worked out great for this use case, and all of the holes end up nicely aligned and worked out great. After machining these headpieces, it's time to finish them. Just straight off the machine, they look fine, but I want a nice high quality finish. So I have made 2 different versions here for different builds that I'm working on. One is a brass version. That one I just sanded and polished up to a nice mirror shine. It goes great together with these gold frets, brass nut, and otherwise gold hardware as well. And I think that turned out absolutely stunning. For the aluminum version, I will be anodizing them. So I'm also sanding them up to get rid of all of the machining marks and leave a nice finish. And then I'm using my kind of DIY anodizing setup. Now, if you're a long-time watcher of the channel, you might have already seen this. I'm using a fairly simple setup here. I don't want to really get into the details here because I'm not enough of an expert to teach you how to do it. But if you look online, you will find lots of guides of DIY anodizing at home, and it's fairly straightforward. First, you need to clean your parts very thoroughly, make sure that there's absolutely zero oils and residue or of any kind left on them. After that, I'm etching them for a short period. This makes sure to get rid of any natural oxides that have already formed. Now I machined these very recently, so there hasn't been a lot of time to create any oxides, but if you're anodizing something that has been sitting out for longer or even already is anodized, then you want to make sure to etch away all of the natural oxides. After that, I'm going into the anodizing bath here, applying some current and letting them sit for about 20 minutes. This is the actual anodizing step, but what many of you probably know from anodizing is the coloring. That's the next step. So for this, I'm heating up this black dye to around 60 degrees Celsius. And then after I'm done with the anodizing itself, I'm rinsing off all of the acid, making sure that they're nice and clean, and then they're going into the hot dye and just kind of staying in there for another like 10 minutes or so. Within a couple of seconds, you will start seeing if the dye takes. If it takes, that means that the anodizing was successful, and you can just leave it in there for like 10 minutes or so to get the deepest color. If the color doesn't really take, which happened on one of the headpieces, that means that the anodizing didn't work. Probably you didn't have a good enough connection on the electrical part, so that means you can just start over, etch away any oxides that did form, and redo the anodizing step. Then, as a final step after the dyeing and boiling them in just regular boiling water for about 20 minutes. This sets the dye and closes up all of the pores to make sure that it doesn't get stained by anything and is nice and durable. With that, now we have these nice looking black aluminum parts that are also a lot more sturdy. Even if I was leaving them just natural aluminum color, I would still definitely want to anodize them, because the raw aluminum scratches very easily, and tightening the screws too many times will also wear out the threads. However, the anodized aluminum has a much harder surface. It doesn't scratch very easily anymore at all, and this is very important if you want to have your parts look nice for a long time. Now, of course, I didn't just make 6-string versions. You also saw me making some 8-string versions here for another build. And once I have a 7-string build that will need my headpieces, I of course will make those as well. Overall, I'm super happy with how these turned out. I really like the look of them. They kind of look very minimalistic and simple, but have all of the features that I want in them. And it's much easier to install them than any of the single headpieces. Now, whether I'm saving money on them compared to buying the actually quite expensive commercial ones, probably not if I value my time. Making them one by one here, it takes quite a lot of time. Setting everything up on the CNC, loading all the tools, machining it, that part actually is fairly quick. But then cleaning up the machine and sanding them by hand to a nice finish, anodizing them, all of this takes many hours, so probably not actually saving money. In the future, I would want to replace the sanding step probably with some bead blasting, but in the current workshop I do not have space for that kind of setup. I could also reduce the amount of sanding I have to do by kind of improving my tool paths a bit, and maybe using some higher end tooling that is specifically meant for this job. I just kind of used whatever I had on hand here, and the finish is acceptable but not great. So with that, I don't want to drag the video out any longer. What do you guys like about these headpieces? Do you think they're nice? You prefer them over single headpieces? Let me know down in the comments. So thank you guys for watching. Make sure to like, comment, subscribe, all that good stuff, and I'll see you next time.